Hi students, many times we have seen such beautiful pictures of huge transmission towers carrying long transmission lines under different backdrops. These are the transmission towers carrying double circuit lines. This is the cross arm in the transmission tower. This is the insulator. This is the insulator in the other side. These are the conductors. At the top of the tower, you can see one thin conductor going. This is the earth wire, which protects the entire transmission system from lightning strokes. This is a conductor of R phase or A phase. This is the conductor in the B phase. This is the conductor in the C phase. So this is one three-phase system. The other side also we have the conductors. Let it be A dash, B dash, and C dash. So here we have two sets of three-phase systems. So we call it double circuit line. And this double circuit line has greater reliability because even if one of the system fails, the other three-phase system can transmit the power. And the power handling capacity of double circuit line is higher when compared to that of the single circuit line. Suppose this is the position of the three conductors A, B, C, and these are the conductors A dash, B dash, and C dash. It is just like what we saw in the transmission tower. If you find out the inductance LA, LB, and LC, these values will be different. For different phases, we will be getting different inductance. So the voltage drops will also be different. Actually, we want to have the same inductance in all the three phases. For that, after a certain length of transmission, we have to change the position of the conductor. We have to transpose the conductors. So this A phase conductor will be brought to this position, and the B will be brought to this position, and this conductor will be brought to the first position. So this is the conductors in the second position. Then again, after a certain length of transmission, these positions will be shifted. So this A phase comes here. So by transposing the conductors, the inductance of all the three phases will be the same because all the conductors are getting all the positions. So the flux linkages will be same. So the inductances will also be the same for all the three phases. This distance is D1. This is also D1. Here the distance is D2. This is the length of the cross arms. And this distance is equal to, this is the diagonal or the hypotenuse of this triangle, that is root of d1 square plus d2 square. I call it small diagonal. What is this big diagonal? It's the diagonal or the hypotenuse of big triangle. It is root of 2d1 the whole square plus d2 square. So this is the big diagonal and this is the small diagonal. Now we are going to find out the inductance of A phase. In order to get the inductance of A phase, I need to find out the flux linkage psi A. So at these three positions, I will find out psi A1, psi A2, and this is psi A3. Then I will find out the average of these three flux linkages. I'll get psi A, then I can easily find out the inductance. Inductance is equal to psi A divided by IA. So this is what we are going to do in this derivation. So before start deriving the inductance, you can remember a couple of formulas in the logarithm. One is log A plus log B is equal to log AB. It's the basic formula. Then you can remember x log D is equal to log D raised to x. The same formula can also be written as 1 by x log D is equal to log D raised to 1 by x. So you can remember these formulas. Now psi A1 is the flux linkage of the conductor A at the position 1. This is equal to 2 into 10 raised to minus 7 into the flux due to A phase conductors, IA into the flux due to its own current, where the length is R dash, logarithm with the base E, plus there is one more conductor in the A phase. What is the distance here? The big diagonal. That is log 1 by square root of 4 d1 square plus d2 square. Then the flux linkage due to B phase conductors, IB into, these are the two B phase conductors. The distances are d1 and the small diagonal. Current is IB into log 1 by d1 plus log 1 by root of d1 square plus d2 square, plus the flux linkage due to the third conductor, third phase IC. So these are the C phase conductors. The distances are 2d1 and d2. All logarithm terms are with the base E. Similarly, we have to find out psi A2 is the flux linkage of the conductor A at the position 2. It's equal to 2 into 10 raised to minus 7 into IA into the flux due to its own current. It is log 1 by R dash plus we have one more A phase conductor. The flux due to that conductor is log 1 by the distance is d2 plus the flux due to the B phase conductors, IB into, these are the two B phase conductors here. The distances are log 1 by d1, the log 1 by root of d1 square plus d2 square plus the flux due to the C phase conductors. These are the C phase conductors where the distances are d1 and the small diagonal. The distance is d1 plus where the distance is the small diagonal. It is d1 square plus d2 square. Similarly, we can find out psi A3 is the flux linkages of the conductor A at the third position. It's 2 into 10 raised to minus 7 into flux due to A phase conductors. The flux due to its own current plus this is my second A phase conductor. The distance is big diagonal. This log 1 by the big diagonal is 4 d1 square plus d2 square plus the flux due to B phase conductors. These are the B phase conductors here. The distances are d1 and the small diagonal. One by d1 plus log this is 1 by 2 d1. Here it is 1 by d2 plus IC into log. These are the C phase conductors. The distances are 1 by d1 and here the distance is the small diagonal. Root of d1 square plus d2 square. Now we have to find out the average flux linkage. So psi A is equal to psi A1 plus psi A2 plus psi A3 divided by 3. So psi A is equal to 2 into 10 raised to minus 7 divided by 3 into IA into, in IA we have 3 log 1 by r dash terms. It's 3 log 1 by r dash plus log 1 by d2 term is there. Log 1 by d2 plus there are two similar terms, log 1 by root of 4 d1 square plus d2 square. This is in the form of log A plus log B. So this is equal to log AB. So here the roots will be getting cancelled. So this becomes log 1 by 4 d1 square plus d2 square plus IB into the IB we have 2 log d1 log 1 by d1 terms and there is one log 1 by 2d1 term plus log 1 by 2d1 term plus log 1 by d2 term plus, we have two similar terms, so the square root will be cancelled. One by d1 square plus d2 square. Plus IC into log 1 by d1 terms. We have two terms there. This IC into there are two terms, so it becomes 2 log 1 by d1 plus log 1 by 2d1. 1 by 2d1 plus log 1 by d2. All are with base e plus log, there are two similar terms, so square root will be cancelled. d1 square plus d2 square. If you look at this IB terms and IC term, these two terms will be the same. So this is our IC. So this is equal to 2 into 10 raised to minus 7 divided by 3 into IA into, this 3 can be brought within the logarithm term, so it becomes log 1 by r dash cube plus log 1 by d2 plus log 1 by 4 d1 square plus d2 square plus IB and IC have the same terms, so IB plus IC into, again this 2 can be brought within the logarithmic term, it becomes log 1 by d1 square . 1 by d1 square plus log 1 by 2d1 plus log 1 by d2 all are with base e plus log 1 by d1 square plus d2 square. This IB plus IC can be written as minus IA because you know IA plus IB plus IC is equal to 0. So IB plus IC can be written as minus IA. So this is equal to 2 into 10 raised to minus 7 divided by 3 into IA into log. So this is in the form of log A plus B plus log C. That becomes log 1 by r dash cube into d2 into 4 d1 square plus d2 square minus ia into log 1 by d1 square into 2d1, so it becomes 2d1 cube into d2 into d1 square plus d2 square. So this is equal to 2 into 10 raised to minus 7 divided by 3 into this minus of log 1 by d can be written as log d. So combining these two terms, it becomes log. So this part comes in the numerator. That becomes everything with the base e. 2 d1 cube d2 d1 square plus d2 square, because minus log 1 by d is log d. The denominator we have r dash cube d2 4 d1 square plus d2 square, and the d2 will be getting cancelled. So it becomes 2 into 10 raised to minus 7 by 3 ia into log 2 d1 cube divided by r dash cube into d1 square plus d2 square divided by 4 d1 square plus d2 square. And we have to find out the inductance. LA is equal to, as you know, it is psi A divided by IA. So the current term will be cancelled. The inductance is equal to 2 into 10 raised to minus 7 divided by 3 into log with the base E 2 d1 cube divided by r dash cube to d1 square plus d2 square divided by 4 d1 square plus d2 square. This is equal to, now this is 1 by 3 log function. As you know, 1 by x log d can be written as log d raised to 1 by x. So all these terms will be getting 1 by 3 at its power. It becomes 2 into 10 raised to minus 7 log 2 raised to 1 by 3. This 1 by 3 and power 3 will be cancelled. This d1 divided by r dash into d1 square plus d2 square, the whole raised to 1 by 3 divided by this 4 d1 square plus d2 square, the whole raised to 1 by 3. So this is the inductance of the conductor A. So similarly in the phase A, we have two conductors. The conductor A and A dash. What is the phase inductance then? Phase inductance is equal to LA by 2 because we have two conductors in parallel. We have two conductors in parallel. The effective inductance will be LA by 2. So this is equal to our phase inductance, or the A phase inductance is equal to 2 into 10 raised to minus 7 divided by 2. This is the inductance of a single conductor. But in each phase we have two conductors as it is a double circuit line. Log 2 raised to 1 by 3 d1 divided by r dash into d1 square plus d2 square the whole raised to 1 by 3 the whole divided by 4 d1 square plus d2 square the whole raised to 1 by 3. Again, this 2 can be brought within the logarithm term. As you know, 1 by x log d is equal to log d raised to 1 by x. So all the terms within the logarithm will be getting this 1 by x. That it is 1 by 2. So this is equal to 2 into 10 raised to minus 7 log 2 raised to, it becomes 1 by 6. It's 1 by 2 into 1 by 3. It is d1 by r dash raised to 1 by 2 into d1 square plus d2 square the whole raised to 1 by 6 divided by 4 d1 square plus d2 square the whole raised to 1 by 6. So this is the inductance in Henry per meter. This is the A phase inductance. And usually this d2 will be much greater than d1. So this d1 term has no effect compared to d2. d1 is much smaller than d2. So this is approximately equal to 0. So this terms d2 square will be getting cancelled. So this inductance is equal to 2 into 10 raised to minus 7 log 2 raised to 1 by 6 d1 by r dash the whole raised to 1 by 2 Henry per meter. This is the A phase inductance. This is our A phase inductance. This will be same for B phase and C phase. Because we have the transposed conductors in all the three phases, we get the same amount of inductance. But its unit is Henry per meter because we assume that we have a length of 1 meter conductor.